Factoring expressions of the form of x squared plus bx plus c, part 3. Alright, so let's start looking at some examples now dealing directly with quadratic equations, quadratic expressions, pardon. So we have x squared plus 7x plus 12, and they're asking us to factor this equation. Now, these, because the a value, the a coefficient, right, in front of x squared is equal to 1, so we know that this is in this form, right? X squared plus bx plus c, right? Let's write this down here. X squared plus bx plus c, right? So essentially, right, considering the examples that we saw before on our previous video, right, we're looking for two numbers. We're looking for two numbers, right, that multiplied will give us c. So in this case, right, what's the value of a here? Well, it's 1, right? We already know that. What's the value of b here? The value of here is positive 7, and the value of c is positive 12. So essentially, following this, we're looking for two numbers, right, that when we multiply them, we'll get a result of c. In this case, when we multiply them, we're going to get 12. And when we add these same numbers, we want to get b, the value of b, right? So essentially, this is what we're trying to do here. In this example, we're looking for two numbers, so that when you multiply these two numbers, we want to get positive 12. And when we add these same numbers, we want to get positive 7, right? So what are these two numbers? Well, as mentioned before, we know that this quadratic expression is the result of the product of two binomials, right? So the question is, when they're asking us to factor this, they're really asking us what two binomials produce this result, right? What multiplication of two binomials produce this result? So this is how we go about solving this problem. So first, right, this expression is equal to what two binomials? What two binomials? So here, let's prepare these binomials here. Mind you, ignore that part. Pretend there's a limit between there. Okay, so what two binomials? What product of two binomials created this, right? So we know we're gonna have an x here and an x here, because x times x will give us x squared, right? Now, let's look for two numbers that when we multiply them, we get 12, and when we add them, we get 7, right? And we know that the product is going to be positive, right? And so that means these two numbers are going to have the same sign. They could be either both positive or both negative, because we're going to have a product that is positive, so that's fine. But we know that the addition will be positive, so most likely both these numbers will have to be positive, right? Will have to be positive. So it's going to be positive something times positive something. What are these two numbers that will give us 12? Well, let's start with like 12 times 1. 12 times 1, 12, but if you add them, you get 13, so those are not the numbers. 2 times 6, that gives us 12, but when you add them, you get 8, right? What are the two numbers? Well, how about 4 times 3, right? 4 times 3 will give us 12, and when we add these numbers, we get 7. So we just factored this equation over here. That means that when you multiply these two binomials, the result is going to be this, right? Let me just put here a line indicating that there's a limit. I apologize. Right? And let's double check this, right? Let's double check this. Now let's expand this for some, right? And this is a way also to check whether your factoring has worked, right? So let's expand this. Let's expand the above. That means we do x times x, x squared, right? X times 3, that gives us 3x. And now 4 times x, 4x, right? Plus times plus, plus 4 times 3, 12, right? Let's collect the like terms. X squared plus 7x plus 12. So that gives us the same result of the expression that we were originally asked to factor. So that means that we've factored this properly. That means that these two binomials are the ones that create a result of this, right? So we've just factored this. Okay, so of course when you first start factoring expressions like these, you may want to do this, you may want to follow this format, right? And then if you want to check, you can expand them just to see if your result is correct, right? Let's look at another example, right? And I'll go a little faster on this one, okay? So you can always refer to your first example, example 2a, that the one we just factored, right? Let's look at x squared plus 4x minus 5, right? Same thing. Over here, we're looking for two numbers that when you multiply them, you want to get c. In this case, what's the value of c? Right? It's -5. And when we add these numbers, we want to get 4, right? So let's look at these, right? It's going to be, we're going to multiply two binomials. And what are these two binomials going to be? Well, x times x in order to get x squared. So fine. We know that the product will have to be negative, right? So that means one number will have to be positive, the other one negative. They have to have different signs if we want our product to be negative. So let's put this a positive and a negative, right? So now what are these two numbers? What two numbers will give us 5, -5 when we multiply them, and when we add them 4? So let's start 1 times 5. 1 times 5 gives us 5, yes. And yes, we can get a 4 if we add them, right? So 1 times 5. 1 times 5, that means that the 5 will have to be positive, because when we add them, when we add plus 5 and -1, we're going to get positive 4, right? And when we multiply them, right, we're going to get -5. So positive times negative, negative, 5 times 1, 5, right? And when we add these two, we get 4. All right, and of course, you can double check this by expanding, right? Let's look at one more example, right? Example 3, and I'm running a little bit out of time, but that's fine. Let's look at one more example here. Let's leave this one here for a while just as a reference, right? Same thing. Let's look at this one, example 3b. Right. Same thing over here. We're looking for two numbers that multiplied, right, will give us positive 21, and when we add these two numbers, we want to get -10. Right? So same thing here. What are these two numbers? What are these two numbers? Right? Well, a and a to get a squared. Right? The product will have to be positive, so that means both of these numbers will have to have the same signs. Either both positive to get a positive product, or both negative to get a negative product. Now we know that the sum will have to be -10. Right? So that means that these two numbers most likely will both be negative. Right? Now what two numbers will give us 21? So 7 times 3 gives us 21, and when we add them, we can get -10. All right? Okay, you can complete the rest of the exercises, and any questions, we'll take them up again when we meet.